This video will cover the second page of notes for the topic of rational graphs. The top of this page has the steps on how to graph rational functions. Remember, the first thing that it states is that our function must be a rational expression in lowest terms. What that means to us is that we're going to have to make sure that we factor when possible and reduce our fractions that are in fractored form. But after we do that, we should be able to find our domain as well as our vertical asymptotes. Then after that, we're going to find our horizontal or oblique asymptotes. We're going to find our y-intercept if it's possible. That's when we let x equal to 0 and we solve for y. Then after that, we're going to go find the x-intercepts. That's when we let our function equal to 0 and solve for x. We will actually be skipping number 5, so let's not worry about that. We will sit there and do the step number 6, which is to plot our points that we have, use our parent functions to help guide us what our graph should look like. And then obviously we will complete our graph or sketch by connecting points as well as making smooth curves. For example number 1, our job is to find the asymptotes as well as to graph, and we have f of x is equal to 2x squared plus 5x minus 3 divided by x plus 1. So the first thing I'm going to do is I'm going to factor f of x. We're going to factor the numerator so that we can see that its factored form is 2x minus 1, x plus 3. The denominator still stays as x plus 1. We always want to start with factoring the numerator and the denominator. We'll see why in a minute, but the big thing that you need to practice on is making sure you can factor. Once we did that, I am going to go over these 7 steps. Remember, we're going to skip step number 5, and in order for us to graph our rational function. So the first thing we need domain as well as vertical asymptotes. So notice I have listed the domain here. Why do I know that from the domain? Remember, we cannot let the denominator equal to 0. If it does equal to 0, that's going to give us our vertical asymptote. From there, we know that that means that x cannot equal to -1 because then it makes our function undefined. So our domain lists every number except for -1. The second thing we need to do is we need to find our horizontal or oblique asymptotes. So let's take a look at finding the degree of the polynomial at the top. And we do that. That degree is going to be 2. We find the degree of the polynomial at the bottom. That's a degree of 1. And we can see that we have top-heavy. If it's top-heavy, that means that it will be an oblique asymptote. How do we find this oblique asymptote? We're going to use synthetic division, that's this part right here, in order to find our oblique asymptote. So what we did is we got the 2, the 5, and the -3 and put those up here. Then we solved our denominator for 0. That's how we got our -1 that goes inside of our box. We did synthetic division. We find that this is my oblique asymptote. This will tell me how to graph it. We'll talk about that in just a second. The third thing we need to do is to go find the y-intercept. Remember, that's when we let x equal to 0. So we can put this to be 0, this to be 0, and this to be 0. We'll see at the top we'll get -3. At the bottom we'll get +1. So that's how we found this y value here. For step number 4, our job is to find the x-intercepts. So in order to do that, we're going to let our function equal to 0. So let's come down here and let's let our function equal to 0. So I'm going to show you something that we had 2x squared plus 5x minus 3 over x plus 1. If we let that equal to 0 and we don't like fractions, I will multiply both sides by x plus 1. When I multiply both sides by x plus 1, where x plus 1's in the numerator and denominator cancel out and just leaves me with 2x squared plus 5x minus 3. On the right side, when I do 0 times x plus 1, that's going to equal to 0. That's this side right here. So if you have a rational function and you're trying to find the x-intercepts, just get the numerator and set that numerator equal to 0. So that's what I did here. I got 2x squared plus 5x minus 3 is equal to 0. This should remind you of the quadratic unit where we can factor, which we already did that up above. We can get the factored form and let that equal to 0. We can set each factor equal to 0 so that we can solve for x. When we do that, those are our x values for our x-intercept. So we have found the two x-intercepts. One of them is 1/2 comma 0. The other one is -3 comma 0. We said we were going to skip step number 5, so let's go to step number 6. Step number 6 says for us to plot our points and then we're going to complete our sketch. So let's do that. So in our graph, we're going to graph our y-intercept. So I'm just going to go down our list here. For number 1, we know our vertical asymptote is -1. You can see that right here in blue. So I will go over it in blue right here. Then the next thing we found in green, I'm going to go over my oblique asymptote. So that's going to graph this line. So I'm going to go up to +3, 1, 2, 3. Then I'm going to use my slope of 2. So I'm going to go up 2 and over 1, or down 2 and over 1, and down 2 and over 1. And we can see this line right here. And you can see it kind of green. So now we've done the two asymptotes. We can do our y-intercept at 0, -3. That would be this point right here. So I'm going to put that in black. Then the next thing we're going to do is we're going to do our x-intercepts. So one of them was at 1/2 0 and the other one was at -3 0, which we already have that one marked. Then let's take a look at our fraction that has our remainder. That's this guy right here. So we're looking at the remainder, we put it over our divisor, we have -6 over x plus 1. Remember, we can write that as -6 times 1 over x plus 1. Our parent function is 1 over x, so our graph should look like that. But because of the negative, it's going to flip. And because of the 6, we have a multiplier. So essentially, if I was going to graph, I go to my new origin, I go over 1, and then I'm going to go down 6. So here's my new origin. I go over 1 and then I go down 6. 1, 2, 3, 4, 5, 6. So it should be down here. And then we're just going to know that within our asymptotes, we're going to do this particular graph here. So that's the reason why I don't go in between my two asymptotes. I get to my points that I have and I'm just going to connect them and make them go towards our asymptotes that they have on that side. So this is going to go towards the asymptote. It's going to go towards the asymptote. And that concludes this video.